Hello, my name is Frederick LeGuins. I'm General Manager for ES3 Southeast Operations. We're located in Warner Robins, Georgia, right across from Robins Air Force Base. At our location, we currently have 5 cold spray systems ranging from low pressure to high pressure. And we're doing development work for the DoD, developing parameters, cold spray repairs, and doing all the validation testing. Today, I will be presenting on U.S. Navy ADAPT SBIR topic N201-X02. And this is focus area 9, where we're looking at cold spray, sustainment, and modernization for the Navy depots. This slide provides an overview of ES3. We are a woman-owned small business founded in 2000. We are considered a high-end engineering firm. We do engineering consulting, design and development, technical support for the DoD, the commercial aviation industry, and other industry sectors as well. As you can see from the slide, within our company, we pretty much have every major engineering technical discipline represented, as well as chemists, biologists, logisticians, technicians, mechanics, pretty much any category that we need to help support our core competencies. Although we are small in size as a business, we are recognized across the industry as a leader in aircraft and landing gear expertise. In doing so, we've developed an R&D niche and become really a powerhouse, developing different technologies, doing validation testing, things of that nature to help support our core competencies. If you took a snapshot of our company today, this slide will cover our current core capabilities, but this seems to be evolving every day as we continue to grow our customer base, continue to look at different technologies in supporting our customers. As I mentioned in the previous slide, we have become recognized as an R&D success, particularly when it comes to SBIRs. We currently have 32 Phase 1 SBIR programs, and we've successfully transitioned 34 Phase 1 into Phase 2s, and even transitioned some into Phase 3s. The photos show some of our capabilities, thermal spray capabilities there, electroplating, post-water jet stripping, and testing capabilities. These are all things that are kind of evolved from our R&D work. SBIR topic N201-X02 is an open solicitation to address the U.S. Navy's need to develop cold spray repair coatings and application techniques for structural and dimensional repair. For those that are not familiar with cold spray, it is a dynamic gas metal deposition process. It is a non-traditional thermal spray process in that it's non-combustion. It uses kinetic energy to basically ballistically impinge a coating onto a suitable substrate. Metal powders are accelerated by injection into a special design nozzle that creates a high velocity stream of gas. And that through that kinetic energy, you can actually apply those coatings to whatever targeted substrate you want. This technology is taking the DoD and the commercial industry by storm, and it allows you to make repairs on components that are typically not salvageable. This slide lists a few of the operational needs that this cold spray process addresses. Everything from dimensional restoration, structural repair, and even corrosion protection. In many cases, you'll have damage to aircraft components, ship components that require cleanup, and then a subsequent corrosion preventative compound. But you really don't have the means to restore the dimensional or structural integrity of the part. Well, this technique will allow you to do that and do it in a manner that's environmentally friendly. Now, as we continue to see cold spray application and usage grow within the DoD, we are seeing an increased utilization of gases, particularly helium. Helium has become the primary gas utilized with high pressure cold spray system as it facilitates increased gas velocity which allows applications of heavier metallic powders such as your tungsten carbides, your steel alloys, etc. It also has shown superior performance for application of aluminum powders when you compare it to using nitrogen. This is particularly important as users are seeking to get structural credits from the cold spray application. The problem with helium, it is very expensive, making some cold spray repairs cost prohibitive. And then there's always the risk of having supply issues interrupted with the helium. To mitigate this problem, ES3 has developed a gas mixing delivery system which will allow the user to combine helium and nitrogen gas, which will thereby reduce helium usage and still maintain good performance on your coating. The slide shows a photo of the system that we designed and developed that can be used as an external delivery system with any user's cold spray system. The system has automated controls and HMI that allow the user to simply punch in whatever desired mixture ratio they want and then go to their respective system and turn it on. Now, this is a floor model that is shown, but this can easily be augmented into a portable system that can go out into the field as well. The mixed gas delivery system will enable more affordable cold spray repairs by substantially lowering costs compared to pure helium usage. Some of our earlier studies have shown that with as little as 25% reduction in helium usage, we can reduce total cost per minute by more than 50%. This will surely help push the technology to more widespread usage for both depot and field level repair capabilities. This slide lists some of the features of the cold spray system and the associated advantages and benefits. First feature is portability. The cold spray process allows you to do dimensional restoration or structural repairs on aircraft, including in limited access areas. So this provides a huge benefit to the end users because now they have a repair capability that can be used both at the depot or at the field level. The second feature is lower application temperatures. With the cold spray process, you can deposit coatings on substrates at much lower temperatures than typical thermal spray processes. With the lower temperature, you eliminate some of the thermal effects and other oxidation, material deformations that could result from higher temperatures. The huge benefit here is that it allows you to now deposit coatings, both metallic and non-metallic materials, on a diversity of different substrates. Lastly, there's the mixed gas delivery system. As I discussed in the previous slide, this is where you can now use helium and nitrogen mixtures as a carrier gas in conjunction with the cold spray system. This is going to make your coating process more affordable by reducing your costs associated with pure helium systems. Here is the current status of this SBIR effort. We have completed development of the test protocol and designed and manufactured the cold spray mixed gas delivery system. Parameter optimization has been completed on the initial substrates identified by our TPOCs, and we have manufactured test coupons. We are currently in the process of conducting all the validation testing. So how do we transition this technology to the fleet? Our strategy for transition and implementation is pretty straightforward. The first step is to identify applications with our TPOC. This is the groundwork that has to be done up front to identify what applications are out there for our customers, looking at their platforms, seeing what kind of typical damage they're seeing, and then trying to determine if there's a cold spray solution for those applications. Once we've identified these applications, we need to develop parameters for the family of materials to ensure that we're going to get consistent results with the cold spray process. Once we have developed parameters, we'll go through and complete our validation testing, which is currently underway right now for the initial substrates that have been identified by our TPOCs. Finally, once we have solid test data, we'll go through a demonstration and validation process on actual components to prove out the technology. Moving forward, ES3 will continue to transition and implement this technology to help build organic capabilities within the DoD. This includes providing engineering support with identification of applications, development of optimized parameters, and the associated validation testing to get these approved for the DoD. As far as the mixed gas delivery system, we're still in need of completing the validation testing for this current effort, as well as continuing to look for system enhancements. Obviously, we are starting with the DoD as our initial implementation of this technology, but we know in addition to the DoD, this technology is applicable to the commercial, aircraft, ship, automotive, gas and oil, and energy industry sectors. So we will look at engaging these customers in the very near future. Thank you for taking the time to listen to our presentation. Here is a list of the key performers from our ES3 Cold Spray team. You can reach any of us if you have any additional questions or if you would like to discuss some potential cold spray applications. Thank you.